Hello everyone and welcome back to my AI engineering course. So in the previous session, we have covered OpenAI Agent SDK foundations. And before that, in the last 6 sessions, we have covered introduction, why we have created this course, LLM orchestration, building a basic AI agent program with tool calling, then making it little advanced by introducing agentic loop, and then convert it into a reliable agent which can work in production with retry, validation, and error handling, and then finally again converted that reliable agent into a chatbot with Streamlit. Now, if we talk about from this session perspective, knowledge of previous session is something which is required. But knowledge of any session previous to that, till session 6 is recommended, but not strictly required. Why? Because in the previous session, we laid the foundations. We took everything which we were doing manually in the last 6 sessions, in the previous 6 sessions, and handed it to the agent SDK. We found how we can replace manual JSON schema with function tools and making it simpler. We also saw how an agent can wrap LLM instruction with agent model name and tool. We replaced our while agentic loop with runner.run method. And we also use pedantic model to force LLM to return structured JSON, which our SDK can validate and hand it back to us as typed Python object. And lastly, we also covered an important topic called tracing, which finally gave us the ability to see what LLM is doing in the background. So far, so good. Everything is fine. Our agent can work fine. But there is one thing which you can notice. There is only one brain which is operating behind the scene. There is only one agent which is. This kind of setup is good, where your workflow is simple and focused, like you are just summarizing the document. But our production systems are really built like that. So if we talk about from this session, we are now moving ahead from the puzzle based agentic program, and we are moving to build an agentic system which can do the research. So it has to do various tasks. It has to search, it has to analyze, it has to finally format and return us the response. So in a system like that, if we will use one agent, then it will become very much fragile because different models, different tools, and different behavior is needed at every stage. A single agent introduces a single point of failure. One fault and the whole system can run down. And then there is no separation of concerns. Architects and developer can relate to that. Retrieval logic, reasoning logic, formatting logic, all tangled inside one agent. You cannot test one part independently. You cannot swap one part and replace it with something else without touching everything else. And then there's a problem of context window bloat. We know that LLM has a fixed context window. So every tool call, every intermediate result, every message contributes to growing context. Think about that. One set of instructions if it tries to cover every task. This is akin to developing a single function in any software program, and you can understand the complexity it can bring. And finally, the sequential bottleneck. There can be independent subtasks that could run simultaneously, but they are forced to wait for each other to complete. So, as the complexity grows, latency also grows with that. And now, when we know why a single agent is frequently not enough, we can now move toward the slide which describe what we are going to build in this session. So, we are finally moving away from the puzzle agent which we are leveraging since session 2, and we are going to build multi-agent research pipeline. This is because we are going to build something which reflects a real production use case. Our research pipeline needs to search the web, it needs to analyze the points and extract the key themes, and finally return a structured output using the pedantic. And another point to note is we are not going to do it or build it just once. We are going to build it twice using two patterns which are provided by Agent SDK. So the first one is agent as a tool, where there is a central agent, we call it orchestrator, that stays in control throughout. It calls each specialist like a function and owns the final output. And the second is another important concept called handoffs, where the orchestrator delegates completely to the another agent. So in our use case, orchestrator will delegate completely to the search agent and search agent to analyzer agent and analyzer agents to the writer agent. And each agent on its stage for some time and then pass the pattern. Full conversation history flows through the chain. So before now proceeding and building these two agents, I was thinking why not we should first build a multi-agent using the classic way, using the hand rolled way, which we have done till session 6, so that you can appreciate more what SDK is providing in terms of building multi-agent pipeline. So for the sake of speed and moving fast, I have already created two files. One is our environment.env file, which contains the OpenAI API key, and the second is this research agent. So let's quickly see what it does and appreciate what OpenAI provides to us. So if you see here, this is an advanced hand-rolled multi-agent program with an agentic loop. The top statements, the import libraries must be clear to you. We are just loading the environment variables and creating the client in the standard way. What we have done till session 6. So here we have just defined the method call LLM, which is doing nothing but just wrapping the response, the request and response from the LLM. And we need to pass it the system and user. And it is the same function which is then, called by different functions, which we are terming it as an agent. So if you see here, the first agent is the planner agent. We will come to it. The second agent is the search agent. And the third agent is the summarize agent. There is one less agent in comparison to what we will be doing using the OpenAI Agent SDK. But you will get the idea. This is the run function and how it is called. From the mean, we are just running this function synchronously. And if you see here, we are first building the context. So here we are just passing our question, what are the latest development in the quantum technology, quantum computing? And here if you see, we have first built the context and define some variables. And now here is our agentic loop, similar to something which we have developed previously. So in within this while loop, which has some maximum iteration so that it should not run infinitely. And if you see here, first it calls the planner agent. So now let's go to the planner agent. In the planner agent, we have the system message. So you are a planner, given the current state of research task, decide the next step. Reply only with one word, search, summarize, or done. Because if we have seen previously, our agentic frameworks are doing such kind of things on its own, right? You don't need to dictate what the agent needs to call. But in the standard way, you have to do it. So it has to provide one word, search, summarize, done. Use search if more information is needed. Use summarize if enough information has been gathered. And use done if the summary has already been produced. So this is the search, our planner agent. And after that, we have our search agent. Search agent is similar. It is a search specialist. And you simulate a detailed web search. Obviously, we are not doing any searching and all here, as this is just for the demo. And similarly, there is a summarize agent. You are a summarizer, produce a concise two-sentence summary of the content provider. So these are our agent. And if we will see the while loop here, so first of all, it runs the planner agent and get the decision. Obviously, assume the first decision will be the search. And now you will see here the problem started coming up. You have to write your own routing clue. You have to write your own if-else statements. And think about if there are multiple agents, you have to make changes in this if-else statements, increasing the complexity. So this is the context which we are building. So earlier we got the question and now we got the search result, and that is something you are building as a context. It will go to this part and it will produce the summary. And finally, once it is done, decision is done, then the loop is finished and we came out of it. So you see some other problems. The another problem to note here is you are building, as we have said, the context yourself. And the third thing, assume that if LLM has written the decision other than summarize or search or the done, because you cannot always rely on LLM to return the thing which you have aimed for. It may make the small changes. For example, instead of done, it can say finish or complete. Instead of summarize, it can say outline, right? So if these kind of words are written by the LLM, if this is the output which is written by the LLM, you don't have any way to handle it. So your loop will go to the else part and you see like the planner the planner hallucinated a decision outside your if elif. The routine breaks, you cannot handle what you did not anticipate. So and another point to note is you are getting the output not as a structured output, but as a raw string. So these are some of the problems with the when you will develop the program without the SDK. So we'll just quickly mention here. These are the problems which we just gone through. There's a routing glue, and then there's a manual context passing. You see, like we are stitching the context, whereas SDK full conversation history is passed between the agents, and then there is no hallucination breaks. If here in this case, the planner can return verify as I mentioned, and your program breaks, it aborts. If you need to add another specialist, the number of changes required in our code is less, and there is no raw string throughput. So now when you know the problems of building multi-agent system, I think it's the best time you to introduce some of the key features or the concept which we are going to leverage while building the multi-agent system in SDK way. Because these are the features that will make our program simpler as well as efficient. So we have talked about the handoff. It's just a tool called that transfer control to another agent. If we see here, handoff can occur when one agent decides another agent is better suited to continue the task and transfers the control. So simple situation giving here, user asks the question here, I was charged twice for my subscription, can you help? So like the orchestrator agent, the central agent, we can have the trial agent that understand the user's request and decide it is the billing related issue. Like we have some two other agents also, billing agent and tech support agent. And then it performs the handoff to the billing agent. Billing agent then continues the conversation and resolve the issue. Another point to notice is that an agent can have multiple handoffs. The handoff parameter is a list. You can register as many agents you want. So the LLM decides if you have the multiple agents registered as an handoff, it decides which to run, which to delegate based on the context. So, but whatever future program which we are going to build, we are not going to use this particular pattern. Why? Because our program will have a right mix of autonomy and control. Autonomy is in the model control. The model decides when to hand off and what to pass. We do not hard code that trigger. And control is in our hand. So we decide which agents are available to the handoff. This is the first feature. The second is agent as a tool. We talked about it. There is a central orchestrator that remains in command, stays in control. There is no transfer of conversation ownership. Third is runner.run. We covered runner.run sync in the previous session where everything runs sequentially. Now there is another way to run the things, which is using the runner.run, which run the agent asynchronously. Now the pipeline which we are going to build here, the synchronous run makes more sense as we don't have independent sub agents which need to run independently. The search agent will run, then analysis agent will run, and then finally the writer agent will run. But suppose if we see this parallel execution here, we have the three agents which are running independently. So the first is climate agent. Its job is to summarize the latest development in climate change. Similarly, we have economic agent, then the tech agent, and finally synthesis agent, which identify the combination and create the combined report or combined briefing. And that's why this program can leverage async IO library, which can run this method, run parallel method asynchronously. That's why this method is defined with async. But the most important line here is await async together, because it can schedule asynchronous tasks to run independently. So what it means, we can have three agents which we have defined our climate, economic, and tech agents all can run at the same times. And when they finish, and our async IO.gather waits till all of them get finished, and then they combine the results and give it back. So this kind of functionality we are not utilizing, but it is useful to know. The next is web search tool. The web search tool is like, this is a hosted tool provided by OpenAI key. So there is no setup, there is no, because there are external such tools available like Serper.dev also provide the similar functionality. But we are not leveraging that because you have to register, make an account and all those things. Here it is just an hosted tools which we just need to use OpenAI API key to in order to leverage that. When we will use this, you will come to know how it is working. And the next concept is run context wrapper. This is, I think, one of the most important concept, because run context wrapper is what your program sees. So yeah, run context wrapper is how you share programs state across every agent and every tool in the pipeline without passing it manually each time. So if you see here, without the run context wrapper, you suppose you run the search agent, you get some of the results, some of the data, then again you have to pass it to analysis agent, and then you have to pass to the writer agent. So each steps require manually passing, and data lives in the local variables that your program must manually propagate. Run context wrapper means you have the shared workflow state, right? So if you see here, you get some context object, and then you just pass the context to the other object. So each agent simply read from the context. There is no manual wiring. So this is an important context to remember. Another thing to remember, run context wrapper is your program side of conversation. We are not talking about the model conversation history. Model does not see it. So just remember that. And input filters basically, if we so input filters controls what LLM history the next agent sees just before the handover effort. So this is the concept related to handoffs. So here the current agent decide what the, here we talked about written the orchestrator agent, but it can be any agent. So the current agent decide what the receiving agent actually gets. So this actually helps in maintaining the context bloat, right, which we have discussed previously. It helps to streamline that. So keep that in mind. And then we have agent orchestration. There are two ways to orchestrate the agent via the LLM, which we will doing in our code. We are the patterns which we are going to use. So agent decide what to do next using the handoff and tools. This is open-ended, less predictable. And the second thing is via code, like the simpler program which we have seen. You can chain agent explicitly and more deterministically also. So this is for better for cost and speed control. And the last thing to talk about, the question which comes to everybody's mind is whether the OpenAI SDK can work with other LLMs like Claude or Gemini or not. So answer is yes, but with the help of light LLM. But the key constraint is hosted tools like web search tool, which we have mentioned it here, it will not work. So yeah, let's move to our program. So if you remember, we have to code same program, which is our research agent twice, one using handoff as a pattern and another using agent as tool as a design pattern. We will start with agent as a tool design pattern first. So let's go to our Visual Studio Code and we will create a new program. So we created a new file called researchagent s2. Let's me quickly modify the name, and here is our code for the new program. So we have, so what we are building a multi-agent research pipeline using agent as a tool design pattern. So you see the pipeline. We have the central orchestrator, the central agent, which calls all of this agent as a tool. The search agent, analyzer agent, writer agent, and return the structured research report. So the pattern is agent as a tool. Each specialist receives only what the orchestrator passes in. The orchestrator owns the final answer. So there are no hands off here. And these are the pip commands which you can use to install the right library. So these are our libraries on the top, and then we load our .env files to load the Open API key. And this structure you are now well versed with. We are declaring the class, and we want our report to be returned in this particular structure with topics, with key findings, with summary, and with source notes if there are any. And then we are declaring our agents. So the first one is the search agent. We will come to that. The second is the analyzer agent. So we will again come to that. The third agent is the writer agent. And finally, our orchestrator agent. So there are four agents. Now first go to the main method, the method which we will be running. So you see here we are getting the user input as a topic. So the topic, let's say, is what are the latest development in the AI world, and we are just printing it. And with trace on, we are just running our orchestrator agent. And you see here we are running the agent asynchronously because we are using async io.run. And similarly here it is await, and the point to note here, it is not required. We are just demonstrating that both the ways possible using runner.runsync and runner.run in such programs. Obviously, this makes more sense when we are running the agents independently and parallelly with each other, which is not the case in this particular use case. So we are running, just if you see here how much simple is the main method, we're just running the orchestrator, we are getting the report, and we are just printing it if we get the report in this format. Now when we run the orchestrator, let's see what happens. So orchestrator is this particular agent, and have given it the instruction. You are the research orchestrator. And given the topic, run this in sequence. So call search agent with the focus search query, pass the search result to the analysis agent to extract the key points, and then pass the analysis points to the writer agent. So it has to run in this particular sequence. So I also mentioned always run the three steps in order. Do not skip any step. And the key point to note is output type is the research report, the pedantic object which will be got to enforce the structured output. And then the tools, right? So our agents we are registering as a tool. This is the change. We have the agents, but we are registering as a tools. And then let's see after that, because this orchestrator agent run in sequence, so first it will call search agent. Now search agent, as you see here, is nothing but an agent with name and instruction. These are the system instruction for the search agent. You are a web researcher, you will receive a search query, and you call the web search tool and return the result exactly as found. Do not summarize and edit to realize. Return raw search result. So again, in the tools we are calling just the web search tool. Now here calling the tool is important because we have to perform the web search and see how the web search tool is called here. Very simple, very easy way. This web search tool is available. So you know we are importing the web search tool from the OpenAI Agents library. As that is what we have mentioned. There is no setup, nothing. Just you can use it as it is. And we are keeping the search context size as low because we are want to keep our cost control. And once it runs, after that the analyzer agent will be called because the orchestrator agent has written in that way. The analyzer agent job is basically to extract the key points, any patterns, any themes, surprise things, and write the details in the plain bullet points, no fluff. After that, the writer agent is called. This is a technical writer and which produce the output. So you see here like how simple it is to create a program. Here there is no while loop in the classic way. You see here like no if else statements which we have discussed. There is no way agent can produce unexpected output like the way we have described in the classic way when we are developing the multi-agent system. So all those problems, routing glue, manual context passing, hallucination breaking, all these things will not come up. And a part of that, we are getting the pedantic object based output, right? So let's run this program and let's see how it works. There's some error. We're just changing this one particular line. Output type as research report. So yeah, it is asking me to enter the research topic. I will enter what are the latest development in AI world. The it is researching the topic, and you see we have got the response. It took maybe a minute or something, but it has done the research. So there are some key findings, and then if you see it has given me the summary, it has given me the source, right? So it has performed the search in the right way. I think it is giving the 2024 result, which I don't know why. So yeah, this is the way we can develop the program using agent as tool pattern. Now let's write our second program where we will be using handoffs. Let create another Python program file. Right, so this is our second agent. The pattern is handoffs. So orchestrator here handoff to the search agent handoff to the analyzer agent handoff to the writer agent. There are no further handoffs. Each agent take over the full conversation from that point, and orchestrator give up the control after the first handoff. Right. So agent test tool orchestrator call the specialist we have seen, but it stays in control. Right. If we see here, it stays in control. It is calling here all the three agents, but it stays in the control, and it is the one which is producing the final output. Now in the handoff, if you will see here, the libraries remains the same. We just add one extra here to remove all tools, which is the input filter. When we are going to when we will discuss this shortly, and we are just loading the first .env file. And the first concept is, yeah, this is the one first concept. We are using the hooks. Now what are the hooks? Hooks basically are the standard functions which are provided, which runs on some specific scenario. For example, here on the tool end, when suppose the search tool has ended, we want to get in our terminal what is the tool name and what is the result. If it is less than 300 words, we are printing it as it is. If it is more than 300 words, we are just printing the first 300 words, right? Similarly, we want to show in our terminal how the handoff is happening. So this is another hook which is provided, and we are just printing how the handoff is actually happening. Once we will print it, you will get to know more. So first is, again, we have our pedantic class, pedantic model. We want our results back in topics, key findings, summary, source, and then we are declaring our agents in the same way. Writer agent is their name instruction, but here, so, say we have the output type. In the previous one, there is no output type because writer was not the agent which has to giving the result back. Here, writer is the final agent which will give the result back. So here the final agent in the previous program is our orchestrator. See the difference. So here we are declaring the output type in the writer agent. Similarly, analyzer agent, again we have the name and instruction doing the same things, get the raw result from the search agent, and it extract the most factual point, pattern, anything notable, right? And you must call transfer to writer agent and do not write any text after your bullet points, right? So here we are using the handoff. Now you see here it is the handoff, and in writer agent, because it is the terminal agent, so there is no handoff, but analyzer agent has to hand off to this writer agent. And we have used the input filter. See, like, remove all tools. So whatever is the tool noise which is produced, if you have seen, then it will be automatically removed. We have seen in our previous program. I wish I can show you. Yeah, so if you see here, this program which we have developed some time back, this is the tool history, right? Whenever internally the LLM runs, they create this kind of tool history, right? So these kind of messages are not required when we have to pass the result from analysis agent to the writer agent, because all it is interested is what the writer has produced. So we are just stripping off all this tool noise before passing the details to the writer agent. And then, yes, the first agent is the search agent, and it has to call the web search tool, which we have seen in the previous program also. And there's a one setting called model settings, which is ensuring this tool is always called. It is not that the model is producing the search results on its own, but it has to call this tool in order to produce the result. And then this is an orchestrator. See, becomes very simple. All it is doing it is just handing over to the search agent. Right, and then this is the main program which is mostly similar, but beside only one difference is we are just initializing the hooks, and with traces on we are running our runner.run, which is runner.run is asynchronous. We have declared the method as asynchronous and then passing the hooks automatically. The orchestrator will call the writer agent will call the analyzer agent will call the search result. All these things will happen automatically, and then the report is produced, and this is the standard way we are printing the report. How these programs can be built, this looks much simpler, very easy to build, very clean and structured. Now let's run this program also and see how it behaves. Running Python, changing the question this time. And if you see here, by hooks, it is printing how the handoff is happening. So research agent has got it showing our code. Research has transferred to our research agent, search to analyzer to writer, and here these are our findings, right? So key findings are there, then summary is there, source is there. So whatever we have described, the results are being. So I hope, like, building the program, multi-agent program using the OpenAI SDK with some of these key concepts are clear to you. How now let's quickly see how the tracing is happening. So if we have we have visited platform.openai.com/traces, and if you see here, both of our programs which we have run are registered here. The tracing has happened. Let's quickly see how it has worked. So this is the traces of research agent as a tool. And if you see on the top, research orchestrator always remain in the command. And the time it took is the creation time of all the agent, whether it's the search agent, whether it's the analyze agent, and whether it's the writer agent. So if we quickly see, we have the three tools called, this is the tool called search web, and within it, it spawns the search agent. Similarly, analyzer agent lives within the analyze results tool, and writer agent lives within the write report tool. If we see the code also, we see here, like, these are the three tool called search web, analyze result, and write reports, and they are calling and they are spawning these three agents, which we are just seeing here. So the search result is producing some, it is a function call, it is producing some output. And similarly, analyze result, we see here, it is taking the whatever is the output of search result, which is the raw search results. It is taking that as an input and producing some output. You see, these are the outputs. And finally, our writer agent is basically formatting the result. It is showing the topic, it is showing the our key finding, it is showing the conclusion as per our the pedantic model. Similarly, if we see the handoff, it is quite clear. Here the research agent is there, but it runs very short span of time and quickly hand off to the search agent. You see here, it is not the cumulative time here, but it passes the baton to the search agent. Similarly, search agent is passing the baton to the agent, and the analyzer agent basically is passing to the writer agent, which is giving us the final output. So it took it just 7 seconds, but if you see here in research agent as a tool, it took 68 seconds. I don't know the full reason, but for such kind of linear program, that's why I think handoff seems like a better choice. So if we will go through the positive and negatives of both design patterns, we can see here for agent as a tool, we know orchestrator stays in the control, so output type sits in the orchestrator. And structure output is guaranteed from one place. It is easier to debug, it is easier to modify the sequence. Because if something goes wrong, you know that the orchestrator is the decision maker. Similarly, the disadvantages. Agent passes that summary of the search result to the analyzer. The analyzer has no way to look back at the raw result itself. So this is the disadvantages, and in hands-off you will not find this kind of situation. Here the orchestrator can become the bottleneck. All the context flow through it. Now we will talk about the handoffs. Each agent here receives the full conversation history, right? And but you have an option to remove the tool noise if you need using this command. So, and similarly, its disadvantage, and I think, yeah, it is more natural for the linear pipeline. That's what just we talked about. Disadvantage, orchestrator gives up the control after the first handoff. It cannot intervene if something output type has to move to the terminal agent. We know that it is the writer agent which is finally producing the output, the last agent, but it is slightly less obvious, right? And it is hard to change the sequence. So this kind of linear pipeline like this we have mentioned here, handoffs is arguably the most natural fit for something where you need to make dynamic decision based on what each specialist or each specialist agent returns, then agent as a tool is the better choice. So guys, I think with that we have reached to the end of the session. It has already become very big. In the next session, we will cover even more interesting topic called guardrails and tripwire, because we know running the production program without safety is just like keeping your front door open. So the guardrails and tripwires provide the runtime checks so that your program remains safe, predictable, and as per expectation and as per what your workflow requirement is. So see you soon in the next session. Till then, bye from my side. Thank you.